Every year, more than 10 billion square meters of drywall are produced worldwide, enough to cover millions of homes from the United States to Europe. This seemingly simple material has become the very backbone of modern construction. Yet the journey of turning raw minerals into the flat walls we see every day hides an incredibly complex industrial process. In this video, the Factorian takes you inside massive factories to uncover how millions of drywall sheets are made and why they've become the #1 choice in construction around the globe. Let's dive in. Drywall overview. Over 95% of homes in the U.S. use drywall for their walls and ceilings, making it the most common material in residential construction. Each sheet is made with a core of gypsum powder, ground and pressed tightly between 2 layers of tough industrial paper. This mix creates panels that are lightweight, fire-resistant, and provide better sound insulation than many traditional materials. In the U.S., a standard 4 by 8 foot sheet of drywall costs around $10 to $20. While drywall costs a bit more upfront than simple wood or plastic panels, its quick installation and low maintenance make it well worth the investment in the long run. Gypsum mining. The first step in making a gypsum board is extracting gypsum from massive mountain ranges where this mineral lies deep underground and can only be accessed through large open-pit mines. Powerful drills bore holes dozens of meters deep, creating shafts strong enough to hold explosives. Specially designed charges for mining are packed deep into the rock so that when detonated, entire layers of gypsum break free from the mountain. Thanks to these carefully calculated blasts, the mineral is released and made ready for the next stage of its journey, becoming an essential material in modern construction. After that, once the signal comes from the chief supervisor, the blast is triggered, sending thousands of tons of gypsum crashing free from the mountainside. Massive excavators move in on the piles of freshly blasted gypsum, scooping up chunks that weigh several tons at a time. Each machine works in rhythm, dumping the mineral straight into the beds of smaller specialized trucks. These trucks rumble down dusty paths, carrying the gypsum to a temporary staging area. There, the loads are transferred once again, this time into giant heavy-duty haulers built to handle massive volumes. From that point, the gypsum begins its journey to the processing plant, where raw stone will be transformed into a material essential for construction. Drywall factory. Truckloads of gypsum rocks roll steadily into the plant's receiving area. Each truck can haul several dozen tons, dumping straight into a massive storage yard right next to the primary processing line. Engineers on site record the numbers and manage how the raw material is distributed, getting it ready for the first stage of crushing. On average, this facility takes in and processes more than 100 trucks a day, adding up to thousands of tons of raw gypsum entering the production flow. Next, excavators move into the storage yard, scooping up massive loads of gypsum rocks piled high in front of them. They work in steady rhythm, dumping the mineral straight into the feed hopper of the production line. From there, the large chunks are carried into giant crushers. This crushing step breaks the rocks down to smaller pieces, making it easier for the drying process that follows. The gypsum crusher works with 2 massive rollers that keep turning, applying heavy pressure on the rocks fed inside. Large chunks get gripped tightly and break apart into smaller pieces under the even force spread across the roller surface. Thanks to its steady motion, the crushing energy is used efficiently, making the size reduction more effective. The result is a continuous flow of gypsum pouring out from below. These gypsum rocks contain as much as 70 to 80% pure gypsum, and they're crushed down into particles only a few millimeters across. However, this process generates a huge amount of dust, and if workers breathe it in over long periods, it can lead to serious illnesses like lung cancer. Once the gypsum is finally ground, it's carried on to massive conveyor belts that move deep into the plant. These belts stretch hundreds of meters long, running non-stop at a steady pace to keep the flow of material uninterrupted. Thanks to the automated transport system, every particle of gypsum is delivered straight to the drying and processing area for the next stage of production. After grinding, the fine gypsum powder is fed into a giant rotary kiln for the heating process. During this stage, calcium sulfate dihydrate slowly loses water and transforms into calcium sulfate hemihydrate, commonly known as calcined gypsum. Flames from the burner shoot directly into the kiln, creating temperatures that range from about 300 degrees Celsius up to over 660 degrees Celsius, with some hot spots reaching close to 7,600 degrees Celsius. The heating is usually prolonged for hours, allowing the water to be released gradually so the crystal structure doesn't break down too quickly. Engineers carefully monitor and adjust the controls, keeping temperature steady in different zones of the kiln. This strict level of control produces high-quality gypsum powder, ready to move on to the next mixing stage. After heating, the gypsum powder is sent to the mixing area to be prepared into a slurry before blending. Before blending the entire batch, technicians take a small sample to the lab for testing. There, the powder is mixed with water in a set ratio and combined with additives like starch or setting time modifiers. The mixture is stirred thoroughly, then monitored for expansion, strength, and setting time. Results are compared against the required quality standards, helping engineers confirm the stability of each production lot. Thanks to this testing step, the plant makes sure the gypsum
going into mass production always meets the highest level of reliability once the formula is finalized. The automated system starts blending the gypsum powder with water and additives in the exact ratio. Each batch of raw material quickly turns into a thick slurry, ready for the next step, molding. Drywall isn't made of just gypsum powder inside. It's tightly sandwiched between two layers of paperboard, which adds strength and prevents warping. That's why massive rolls of paper, stretching hundreds of meters long, are fed into the production line as an essential component. Specialized machines carefully unroll and flatten the paper, keeping the surface smooth and free of creases. Operators stay alert, adjusting speed and tension, so the paper aligns perfectly with the line. This layer acts as the crucial framework, giving the gypsum a solid base to bond with and forming a complete drywall panel. Right after that, the gypsum slurry is powerfully sprayed onto the flattened paper surface. High-speed nozzles spread the slurry evenly, forming a continuous and uniform layer. This allows the gypsum core to bond tightly with the paper, laying the foundation for a complete drywall panel. Right after that, the gypsum slurry is spread over the paper, passing through a massive roller system to set its precise thickness. These rollers are designed to turn continuously at a steady speed, pressing lightly on the surface of the mixture with controlled pressure and accuracy. The entire gypsum layer is leveled evenly from edge to edge. The thickness of a drywall sheet usually ranges from 9 to 15 millimeters, depending on the type of product the plant is making. This step ensures that every drywall panel coming off the line has consistent dimensions, ready to meet the demands of modern construction. Right after the gypsum layer is flattened, an automated spray system mists a thin solution over the surface. This coating works to eliminate tiny air bubbles that form during mixing and spreading. If left untreated, those microbubbles could create voids and weaken the drywall panel. The solution is usually clean, filtered water, sometimes mixed with additives to improve adhesion. The droplets are ultra-fine and evenly distributed, so they don't deform or disrupt the panel as it's taking shape. Thanks to this controlled spraying step, the product keeps a uniform structure and a smoother surface finish. After that, the edges of the drywall panel are precisely shaped by specialized machines, creating clean and even outlines. This step gives the product neat edges, making it easier to join and install at construction sites. Once the drywall panel is fully formed on the conveyor, it moves into the automatic cutting area. Here, sensors precisely measure the length of each panel and send signals for the industrial blades to drop. In perfect sync, the sharp blades run continuously, cutting the sheets into standard sizes like 2.4 meters or 3 meters, depending on production needs. The cutting speed is carefully calibrated to prevent cracks or surface shifts. Afterward, each drywall panel is separated and neatly arranged on the conveyor to move on to the next stage. Thanks to this advanced cutting system, the final product always meets consistent quality standards. The next step is crucial. Each drywall panel is folded, so the paper wrapping tightly hugs the gypsum core inside. The mechanical system uses lifting arms and automatic guides to bend the moving sheet with high precision. As the paper folds over, it forms a sturdy cover holding the gypsum in place and protecting the surface from cracks. Without this paper layer, the gypsum would crumble easily, making transport and installation difficult. At the same time, the paper creates a smooth finish that makes painting or tiling much easier later on. Thanks to this folding process, drywall panels gain the strength and clean appearance they need before reaching the market. After that, the drywall panels are moved into a massive drying chamber to remove any excess moisture left in the core. Inside, the temperature is maintained between about 300 degrees and over 660 degrees depending on the stage, and each drying cycle lasts around 30 minutes. Hot air is evenly distributed across all levels, making sure every panel dries consistently from the inside out. This step gives the drywall the hardness and strength it needs before moving on to the final finishing stage. Once the drywall panels are dry and stable, they move on to the edge sealing line. Machines apply special paper strips along the sides of each panel, both protecting and reinforcing their strength. The rolls come pre-printed with logos, product details, and technical standards running continuously to keep the entire batch consistent. This process not only prevents edge chipping during transport, but also gives the manufacturer clear brand recognition. Forklifts carry stacks of finished drywall into the storage area where they're neatly arranged into tall blocks. Thanks to this system, thousands of drywall panels can be stored efficiently, ready to fill large orders. Organized storage also makes loading faster and safer. When an order comes in, forklifts load each batch of drywall onto specialized trucks. From there, the fleet heads out of the plant, delivering the panels to construction sites and distributors across the market. Once drywall panels leave the factory, they're easy to install thanks to being lightweight, durable, and quick to work with. In the US, more than 90% of homes today use drywall for interior walls and ceilings. The cost is also affordable, just a few dollars for a standard sheet, making it a popular choice. Its convenience and economy have made drywall an almost indispensable material in modern construction. Gypsum recycling process. In Europe, recycling drywall panels has become a common and widely practiced process. On average, each drywall sheet lasts between 30 and 50 years in a building. When a structure is demolished, drywall isn't simply discarded as regular waste, it's collected for recycling. This allows workers to dismantle and sort, giving the material a new life as part of sustainable construction. Once collected, drywall material is transported back to recycling plants, in volumes reaching tens of thousands of tons each month. Recycled drywall costs 2 to 3 times less than gypsum mined from quarries. What's more, it can be recycled up to 10 times while still maintaining nearly the same quality. Recycled drywall is lifted and loaded into the industrial crushers. The panels are ground down into a fine powder. From there, the material moves on to additional processing, preparing it to become the raw ingredient for new drywall panels. Unlike in the US, Europe has developed advanced recycling technology that allows recycled paper to be added into drywall panels. This method not only strengthens the bond of the product, but also reduces the amount of raw material that needs to be mined. The recycled paper mostly comes from industrial and household waste, carefully sorted to remove impurities. When combined with gypsum, it creates a building material that is both durable and environmentally friendly. After that, the recycled gypsum and processed paper are fed into a modern mixing system. These components are combined with water and a few additives to improve bonding strength. The result is a uniform slurry ready to be pressed into new drywall panels. Once mixed, the gypsum slurry is spread out into a wide layer, which at first is still soft and loosely formed. Rollers and flattening systems gradually press down, removing excess air and smoothing the surface. Then automatic blades adjust the thickness, making sure the entire sheet stays uniform from end to end as it moves along the conveyors. The layer is pressed and leveled several more times, turning into a continuous sheet. The long strips of drywall are fed into an automatic cutting machine, where blades drop with precise timing to divide them into panels of standard size. This process runs continuously, ensuring every sheet is uniform in length. After finishing, the drywall panels are neatly stacked into large bundles. Automatic packing machines wrap the edges to protect the surfaces and keep everything secure during transport. This way, the product reaches customers flat, intact, and free from damage. Conclusion. And that's the full journey of how drywall is made. From the Americas to Europe, drywall isn't just present in most homes. It can also be recycled many times to ease the burden on the environment. A material that seems simple at first actually carries a long story of technology and sustainability. If you found this journey interesting, leave a comment and subscribe to The Factor In to discover more fascinating production processes.